Good morning, students. Today let us revise some numericals of electricity and so see the first question. You are given three resistances of 1 ohm, 2 ohm and 3 ohm. Show by diagram how with the help of these resistances you can get. First answer we have to get 6 ohm. So students, by seeing this only, the three resistances that is given, we understand that all are connected in series. So R series is equal to R1 plus R2 plus R3, and I have shown over here R1 is 1 ohm, R2 is 2 ohm and R3 is 3 ohm. So 1 plus 2 plus 3, that is 6 ohm. We have got the answer first one, that is 6 ohm, and all are connected in the series in your diagram. For second question, let us see it, that is case 2. Case 2, we have to get 6 by 11 ohm. 6 by 11 ohm, that means here you see denominator is greater and denominator is greater. So let us see that if all the three we connected parallel, so R parallel we will do it 1 plus 1 by 2. R parallel means 1 by R parallel, 1 plus 1 by 2 plus 1 by 3. So what here we will get it? We will get that is 6. So here 6 plus 3 plus 2, that is 6 to 8. 11 by 6. We have got this 11 by 6 ohm. So R parallel, just reverse it. 6 by 11 ohm. So here all the three resistances are connected in parallel. When you will show in figure, students, I think you are remembering when I used to teach you parallel combination, I have shown you that parallel combination has two common terminal. So here also let's show, we will take one common terminal, 2 and 3, and then you connect your parallel resistance very easily. You will get it, parallel resistance, and again this parallel resistance 3, and both this has common terminal. A circuit has been drawn, that is R1, R2 and R3, and this is, I am naming this X and Y. These two are common terminal, these are parallel connection. So when we connect parallel the three resistances, we will get 6 by 11 ohm. Let's see for third case. Third case, case 3, we have to connect and get R equivalent 1.5 ohm. So student, see here, we have got 1.5 ohm, that means greater than 1, and when you are getting greater than 1, whenever the denominator is less than numerator. For this case, when denominator is less than numerator, then only the answer will come, that is greater than 1. So how we will solve this? Let's start for this, that is R equivalent, and for this first of all connect the two, because R3 is the maximum one and we have to get denominator less. So first of all connect this denominator less and condition is parallel, then only we will get numerator, that is more. So first we connect R1 and R2 series. R1 and R2, directly I am writing RS is equal to R1 plus R2. So here you will get it 1 plus 2 ohm, that is 3 ohm. And then this 3 ohm is connected to R3 parallel. So we will get R by 1 by R equivalent is equal to 1 by 3 ohm plus 1 by 3 ohm, that is R3. And so 3, LCM is 3, and here we will get it, that is 2 by 3, and that is We have got 2 by 3. It is parallel. So reverse it. By reversing, you will get the answer R parallel equivalent is equal to 3 by 2, and that you will get 1.5 ohm. So answer we have got 1.5 ohm. See students, denominator is less 2 and numerator is greater, and so answer we have got 1.5 ohm. Let us see the next question. So students, previous one we have solved 1.5 ohm, and for this draw the circuit diagram. So how will you draw this circuit diagram? You are seeing that we have connected R1 and R2 in series. So you connect R1 and R2 in series. In one we have taken R1, R2 in series, and second one R3 is parallel. So here what we will do, R3 is parallel. We have shown like this, and then from this one common point is there, and then you show the cell, that is potential difference. In another two also you can show this. So here I am naming R1, R2 and R3. So here R1 and R2 is parallel with R3. Next question, which has a higher resistances, a 100 watt bulb or a 25 watt bulb, and by how many times? So let's see here. First case is 100 watt bulb, means power is given, that is 100 watt, which has higher resistance. Means remember the formula that how power is related to resistance, and so that formula is P is equal to V square by R. P is equal to V square by R. By here only you are seeing that power is inversely proportional to resistance. If resistance increases, power decreases. If resistance decreases, power increases. Here resistance we can find out. I am for first case, for 100 watt bulb I am writing R1. So R for bulb, and R1, so you will get, we get V square by P. V square by P, that means, may I write this one? V square by P is 100 watt, that means by 100 watt. One case we have got this one. For second case, 25 watt bulb, see directly I am writing for second case, P is equal to 25 watt bulb, watt. So I am writing R2 directly from this formula, V square by P, that means V square by 25. So see here, 25 is less comparison to 100 watt. So this for 25 watt resistance will be more because it is inversely proportional. Here I am showing you also. Last question is, and how many times? So find out the ratio, because whenever we are finding out the greater than or less than or number of times, we are finding out the ratio. So ratio, let's find out, that is R2 by R1. So what you will get? R2 is V square by 25 divided by R1 is V square by 100. So here you will get it V square by 25 into 100 by V square cancelled, 25 4s are 100. So R2 by R1 is equal to 4, means R2 is equal to 4 times R1, which shows the result as R2 is greater than R1. That means just see inversely proportional. P is 25 watt less than 100 watt. So its resistance is greater than comparative to R1. Let's see the next question. The question is, three 2 ohm resistors are connected shown in figure. So see, this is the figure. A 2 ohm resistor, B 2 ohm resistor and C 2 ohm resistor. Each of them dissipates energy and can withstand a maximum power of 18 watt. Each of them can withstand a maximum power of 18 watt without melting. Find the maximum current that can flow through the three resistors. So here students, we have to find out the maximum current flow through each resistor and power is given. So first of all, always I have told you that what is given, according to that you link what we have to calculate. So here power is given for each one, that is 18 watt. And resistance is given of each one. So in the formula of power, resistance is given and power is given. We have to calculate the current. So which formula we will use? Say this, P is equal to I square R. R we have, P we have, I square we can calculate easily. First say this, for point A, I am writing power or for point A. It is connected in series and then you find if I is flowing through A and this I, when it reaches at this point, then only it can divide into two parts, that is two resistors. So whatever the circuit current, that current is flowing through point A, that is the series combination. Both the currents are same. So here we can write I square R is your 2 ohm and power is given 18 watt. So 18 is equal to I square into 2, and as this is I square into 2, answer you will get that I square. You can solve this as you can write this one also as I square is equal to 18 by 2, that is 9 ampere. So here I square we have got 9 ampere, means I is equal to, which implies that I is equal to, we will get 3 ampere. So current through point A, that is 3 ampere. Now you see, point B and point C, both the resistance are same. 2 ohm and 2 ohm. That means equal current both will get because resistance are same. So how we will find this one? As simply, very simply you can do this, that is current through B and C. I am writing IA. Current through A is divided into two parts. Current through A is 3 ampere and it is divided into two parts equally. Why? Because resistance are same in both the cases. So 3 by 2 you will get 1.5 ampere. So both the current, both the resistance, the current will passes through 1.5 ampere and from A it passes through 3 ampere. So let's see the next question. How many 176 ohm resistors are required to carry 5 ampere on a 220 volt line? Again students, let us see what is given in this. So you see, it is given in this. First of all we write given. Given is I is equal to 5 ampere V is equal to 220 volt. From Ohm's law, we know V is equal to IR. That means we can write R is equal to V by I. So we have got this one as R is equal to V by I 220 by 5. So you will get this one as 5 4s are 20 and again 20, 5 4s are 20. So R is equal to 44 ohm. Students, now we have to think that we have to connect it in series or parallel. So you see this. How many? 176 ohm. That means this is more. And what we have got? We have got less 44. If result we have to get less, that means every time it is connected in parallel, then only resultant we are getting less. So how many 176? So let us take one variable. Let the number of resistance, resistances is equal to N. This N we have to connect it in parallel. So you see here in parallel connection, in parallel, we can write this one as 1 by R is equal to 1 by R1 plus 1 by R2 plus dash dash dash. How many times? N times. N times. So can we write this? N, all these are N times. So total will be N, and R1, R2, R3, R4, it is what? It is given 176 ohms. So directly we can write N by 176 because all these are same, 176 ohms. So here 1 by R is equal to 176 ohms. That means 1 by 44 is equal to N by 176 ohms. So N we can find out as there, which implies N is equal to 176 by 44, and so the answer we will get it, that is 4. So number of resistance required is 4. So students, up to here you will revise. It will be very helpful in your coming periodic test. Okay.